Hey everyone, welcome back to Code by Ankita. Today I am breaking down one of the most underrated but insanely powerful upgrades coming to Ethereum EIP-7939, count leading zeros. It adds a new opcode called CLZ, count leading zero. Sounds small, right? In the EVM world, this is a massive. Think of it like giving a basic calculator ability to do square root instantly instead of doing 50 small operations. If you are a smart contract dev, this is the something you must understand because it changes a gas cost, ZK performance, even how future EVM language will be written. So let's break down in a very simple way. So first is, what is EIP? Before we jump to the topic, let's clear a simple basic things. What is EIP? The EIP is a Ethereum improvement proposal, is a basically the official way to upgrade Ethereum. Anytime the EVM changes or we add new opcodes or we upgrade consensus rules, it comes through an EIP. This one EIP-7939, it's introduced a new EVM opcodes, new instruction inside the EVM itself. So it is like adding a new button to the Ethereum computer. Think of it like we are adding one more tool to the toolbox of every smart contract. Like they asked, what is use of EIP? Like standardized way to propose changes to Ethereum, can modify EVM consensus or network behavior, how the EVM consensus work and how the network behavior all the works. That all are things in EVM we discuss in the EIP. And the EIP 7939 introduced the new EVM opcode, and how that works we see in the later slides. But firstly, we understand here what is EIP and how that work. Like EIP's initial phase is like formal idea. Whatever EIP is make with the formal idea. The idea came, and after the draft is creation, what is idea and how that work and all the things that drafts are created, and that draft gives to the developer review, and that developer review on that. Then they are doing some client implementation, and also with the developer and the community both are discussion about this topic, how this work process and all the things they are discussing. And then after they finally conclude, like they understand or they approve, all community and developer both are approved, then they go to the final phase. And the final phase, the core dev vote, means all the core developer are voting. The vote is like, it's a vote is okay for this EIP, then that hard fork to upgrade. Like currently upgrade happened in Ethereum, like at the Fusaka, this is the biggest upgrade happened. So this kind of EIP work, how that work after the EIP, that is going to be the EVM. So the EVM, you can imagine it like a CPU of the Ethereum. It runs all smart contract, but it is a, let's be honest, kind of old school and limited. No floating point numbers, very few bitwise operations, and everything in 256 bit. Missing some bitwise operation like count leading zeros, and that missing operation is exactly what the CLZ solve. So if you want to do some advanced math on EVM right now, it feel like trying to cut a cake with the plastic spoon. What is due by the Ethereum virtual machine? The computer running all Ethereum smart contracts. The EVM is the CPU of the computer. So the in EVM, the all smart contract running. In the stake base, that is a stake base operations operates in 256, means 32 bytes each, the 256 bit. No floating point numbers, that already we say that. Missing basic math operation like CLZ and CTZ. The how Ethereum stake architectures like work, word size detail in the 256 bit small format, and in that 32 bytes per word, that is a fixed size operation and no floating point support. The basic operation push in the like EVM stake basic operation is like a push, add items to top, last in first out LIFO method, and pop removes top item, remove top item and return value. So here the stake structure, like top the stake most recent, whatever the stake is top is the recent, and the bottom stake is the oldest. So the like color is also like the darker one if you go the downside. So this kind of EVM stake architecture work. After that, we understand about what is EIP-7939. We understand the basic concept of EIP and EVM, how that both are connected and how that work. So the what is the new thing introduced in the EIP-7939? EIP-7939 is a Ethereum improvement proposal. This is the name of EIP to add a new instruction to the Ethereum virtual machine. EIP is usually used for the new instruction or new thing added to the EVM. So the engine that runs all smart contract. EVM is the engine that run all smart contract. The instruction is called CLZ. In this EIP, the main thing is CLZ, and CLZ means is count leading zeros. What does it do? You give it a 256-bit number, like this kind of 256-bit number, the starting with the 0 and all are the 0 and the last only 1. So it counts how many zeros at the beginning means that count from the left side, like a most significant bit to it returns count 0 to 256, whatever the count is, like 0 to 256, because they are working only the 256 bit. If the number is 0, it return a 256. If you are confused in that, like we are understand this example, 0 0x8, this is starting from 8 and after all 0, then CLZ doing that 0. Why? Because no leading 0, because here the starting number is 8, not a 0. So if the starting number is start with the number without a 0, then they show the 0, no leading zeros. And the other is 0 and the all are the 0 and the last byte is the 1. So here they do the 255. It means like 255 leading zeros. The last is only 1, so the 255 zeros. And if sometimes the all are zeros, those then CLZ says the 256 all zeros, like special case all zeros, then they do the 256. And if the 1 is only there, then 255, and the starting with 8, then no count 0, like 0. So the like CLZ is stand for the count leading 0. Super simple. Take a number, look at it in binary and count how many zeros appear from the left side. Left side first is a number, not a 0. Then they not count zeros. It's literally the EVM asking how many zeros are the front of the number, front of this number. And this tells you how big the number is in the binary terms. Then the other slide is why was it needed? Now you might think, Ankita, who cares about zeros? But there is a trick. CLZ used everywhere in computer science. Whenever you need to figure out most significant bit, there's tool algorithm, square root approximations, data compression algorithm, and ZK proof math, all are like use in CLZ, like CLZ is used in all these things. Like today, if the smart contract wants the count 0, then they do calculate log₂ x, compute square root x, find the most significant bit MSB, compress data, run ZK proof. This all things we have to count like this. It has to simulate CLZ using a dozen of EVM instruction, like a for this all counting and the CLZ, how we want to count 0, then we use like lot of instruction. The other is like SHR, LT, OR, XOR, byte is 0. What these are, we see in the next slide, but first we do like that. Without the cost today, like without CLZ, what are the costs we having? In a metric, like in metric, gas cost is 184. Currently, the same software we have spending a gas 184 gas. Bytecode is 100 plus bytecode. ZK proof cost 1.6x more than the MUL, and speed is 60x slower than CPU. मतलब 60 times slower than the CPU over speed. And the result is like DeFi apps pay huge because of this, and because all the calculation we done by these all the instructions. Then the what are the result we get? Like DeFi apps pay huge gas. ZK rollups prove slowly. Contracts are bloated. It's like lot of contract to prove that. When the EVM doesn't have count leading 0 instruction, developer must manually build the logic using basic bitwise operation. Currently, we have not CLZ, so all the developers have to manually build these things. So what is SHR? Like now we discuss about these things, instructions. So the SHR means like shift right. Shift all bits right by 1 or n. Use gradually move bits until the first appears, means the first number appears until the move is shift. LT less than compress two values. Use to check if the number has reached 0 or if the shift bit is now 1. Or bitwise or combines bits 1 if the either is 1. Help bit or mask patterns while scanning bits. XOR bitwise XOR 1 if bits differ, 0 if same. Use for toggling and the checking changes between bits. These all are instructions we have to use for the zero count. So you need a CLZ. Right now Ethereum does not have these simple instructions. So devs hacked together 40 to 60 lines in the assembly to mimic it, to find a zero. Assembly just to mimic it. It's like a building on screwdriver every time want to tighten a screw. Then EIP-7939 adds CLZ opcode. Stop simulating, just add CLZ at a real-time instruction. These all are the technical spec. Opcode is 0x1e. Stake input is 1x 256 bit word. Stake output is 1x count 0 minus 256. Guess is 5. Same tire as mul prevents DOS. DOS means denial of service attacks. Return 256 bit if input 0. Means all are the 0. There is no number, then the return 256. Purpose. Hardware style bit counting. No loops. Status last call is this and Fusaka upgrade in 2026. Why 5 guess? Same tire is MUL. MUL means multiple token. Prevents DOS, denial of service attack, not too cheap, and still 30x cheaper than the current code. So if you are a smart contract dev, here's all the technical spec. And this is important because it's not too cheap to cause a DOS, but far cheaper than the current hacks. EIP authors say it around 36 times cheaper and the 90% smaller bytecode than the current emulation. So it's literally free performance upgrade. So how the CLZ work? Push 256-bit number like this way and the last number is 0. Then run CLZ code like this and run from MSB first 1. Then they push like 255. If input 0 means all inputs are 0, then they push 256. Like here also one example that all are first is 0 and the last is 1. So 255 leading 0. So CLZ returns 255, the only 1. So that 1 bit is remaining, 255 bit are all are 0. Before CLZ, current software emulation means before CLZ how we calculate and how the code is look like. Before CLZ, you have to write a 40-60 lines of assembly. Contract are heavy. ZK rollups are slower and gas explodes. Like this way. This is the simple code. EVM assembly, Solidity. Use this as shown. It is a simplified real version of what currently the fastest known CLZ emulation on the EVM, taken from the EIP discussion optimized libraries like Solidity. This kind of contract that work. This contract. This is the more bigger contract, but we have like for the simple one. And after, if like we add the future Solidity with the CLZ after upgrade of Fusaka, that assembly let result CLZX new EVM code 0xC. Only this lines, only the just one line, if we can say that. Then you just call CLZX, one line, one opcode 30 times cheaper and the 90 times smaller, 90% smaller bytecodes. Powerful use cases of that, like log₂x, where the use cases of that, and like simple example for that, log₂x 255 CLZX, that how CLZ helps here. And the fixed point math. sqrt, we use this in the Uniswap v3, v4, powWad inward, that avoid shift loops, that use in Aave and compound, MSB, LSB, that use in bitmaps, data compressions, in call data packing, ZK proof, SP1, RISC, and 0. Here's the ZK and the rollups impact. Why CLZ matter for zero knowledge proof? In zero knowledge proof, how that help and how that matter. Before CLZ, ZK circuits shift operations and the high performance cost. And after CLZ opcode and lower proof cost. ZK circuit emulation shift, higher constraints and expensive proof operations, slower rollups. Here the higher constraints happen. And after CLZ native bit count, CLZ 01E in EVM, 0x1E in EVM. Fewer constraints, fewer proving, cheaper rollups, and the more private on-chain computation. So CLZ is equal to cheaper ZK math, faster proof, and lower rollup cost. Here we are about Fusaka upgrade. Fusaka is the Ethereum largest post-Spectra upgrade, and in this upgrade we are upgrading the new introduced 12 EIPs, and in the 12 EIPs here there are some, and one of them is 7939 CLZ opcode, 7951 SCARP 256 R1 pre-compile, 7935 45M gas limit, 7960 best pre-confirmation. When the CLZ is the smallest, yes, most impactful EVM improvement in the Fusaka upgrade. Smallest fix, but biggest performance jump. Security and the edge cases. Here the related the security about CLZ is CLZ is fully backward compatible, means if you write a smart contract before that upgrade, then also that compatible with that also, and no breaking changes. The only tiny edge case is there. If you already had variable called CLZ, if you put in your smart contract any variable called CLZ, then you have to rename that variable, and that is rare for that. That is a rare thing. You add a name of CLZ as a variable. So here the case x is equal to 0 and the behavior is 256. So the CLZ return 250. Y enables 3 greater than 3, 32 byte skips, 32 byte skip, and the x is equal to max means return 0. Correct? And DOS risk none. Fixed 5 guess stateless. Only 5 guess. Before that we are currently having a 184 guess. And if we include this, then it's only 5 guess. The timeline of 7939 and how that upgrade draft and created, here the stages of that and the dates. The draft is created on 28 April, last call is 28 October, and the DevNet 2 launch, DevNet 3 launch, public testnet, Holeski, Sepolia, and the hoodie. And mainnet activation, mainnet launch is happened in 3 December 2025, means after some days. Here's the name of the author and community. Here's the people behind this EIP. So here's the EIP lead by the vectorized, the creator of Solidity Dev, and also supported by their co-authors is Georgios Konstantopoulos and Joachim Brower, Ben Adams, Giulio Riboffo. Some of the authors are there, and the discussion heavily in Ethereum magicians and about this EIP and the EIP and all the things. There is a heavy discussion happen in Ethereum magician also, and here the content by the Solidity Dev also. They are also saying about this. Basically, some of the smartest people in the Ethereum ecosystem agreed this opcode is a long overdue. So why should you care about this EIP upgrade and all? If you are a developer, then your contracts get cleaner, cheaper, and faster. If you are a DeFi user, then apps become cheaper to use. If you are a ZK systems, for the ZK systems, proof become faster and cheaper. For the entire ecosystem, EVM get closer to the modern CPU behavior without breaking anything. Sometimes the smallest engineering changes create the biggest real-world improvements. So here's our complete the EIP-7939, the count leading 0 opcode, the tiny instruction that speed up the Ethereum, reduce cases, and helps ZK ecosystems. So that is a great update. After launch, we can make a smart contract and many kind of app that made with this EIP. After main launch, the many apps, and there are many apps and all the smart contract consider this, and we are using this EIP to our smart contracts. So our topic is over for now, and so goodbye everyone. We meet in the next video.